Hey everyone, so today's video we're going to look at the nVent 920 heat trace controller and specifically dig into all of the components that are in this heat trace controller panel and then how they all interact and work together. So let's get into it. So this is a typical 920 heat trace control panel. This one's obviously just in our lab, but it's good for demonstration purposes. So the 920 control panel's got a couple elements here. So obviously we've got our terminal blocks that have our incoming voltage and then our outgoing voltage for our heat trace circuits that are located in the field. Typically in a panel like this, you'll also have a set of terminal blocks that are for our DCS or common alarm wiring, and then also RS-485 communication wiring. Now, these modules, I'm going to start with these guys. So these are the 920 current transformer modules, and these things do much more than typical, CT. So not only does this module read current or measure current from the heat trace circuits, but it's also used as the control power to our heat trace controller modules, and then it's also used to do the switching for either a solid state relay, which is most common, or an EMR or a contactor. So the CT modules are, they'll be very specific to either an SSR or an EMR. So this one is, and most common, is configured for solid state relays or the SSRs. So what is happening here is we have our black and white wire, obviously, our supply voltage. And the supply voltage for any of these CTs ranges from 100 to 277 volts. Now, one thing I want to point out is that older heat trace control panels, what we oftentimes see is that the control power will be paralleled from circuit 1A's supply voltage. Now, and then supply voltage will take our 120 volts or 100 volts to 277 volts, and it'll parallel between all of the CT modules within a panel. And this is like very, typically older panels. Now, the risk with this is that we've seen this numerous times, is that somebody will go and do maintenance or do work on circuit 1A, and they'll lock out that breaker, and then you'll lose control voltage and you'll lose power to an entire heat trace panel. So what we like to see is either the control voltage is either paralleled from each individual heat trace circuit. So obviously this panel, if you haven't been able to tell already, has got 3 heat trace circuits on it, or you have a dedicated circuit breaker just for control power for each one of the CT modules. So the next thing to chat about is that there is a RJ45, almost like a Cat5 cable you'll see between the CT module and the 920 control board. This cable serves 2 purposes. Obviously, it's providing power to the 920 module, but then the 920 is also reading current from the CT module, and it's also telling the CT module when to output onto the solid state relay, or the solid state relay should be switching, or an EMR if it had an EMR module. So one thing to note here is that the 920 controller, you probably already know, is a 2-point heat trace controller. That means there's 2 individual heat trace circuits on the 920 module, and you get a CT module per circuit. And what you'll notice is that these connectors that are on the board, if one is disconnected, we still have control voltage on the 920 module. But if both are disconnected is when we lose voltage, or we lose control power. But if we have power from either one, then we get control voltage on the module. The other thing on the modules, on the actual heat trace controller, there's a couple components to it. So I've already loosened all the screws in this module, but you have your interface module. Now, this is not the brains of the 920 heat trace controller, so this can come off and go between any other modules you have in your panel without any repercussions. This is the actual module itself. So if this is taken off, your heat trace circuit is still going to work and function, and you get some basic indication in terms of power, my alarm indication from point A, point B, so circuit 1, circuit 2, and if it's outputting anything to the solid state relays or the EMRs, okay? But this is the actual control module. So I've already loosened all the screws on this because I want to show you the control board. So the control board is where we do all of our external wiring. So whether it be our common alarm wiring, our RS-485 communication, our external inputs, external outputs, or our RTDs, everything gets wired to this control board. The last thing I want to note is related to RS-485 communication. Now, some older heat trace control panels that get RS-485 communication to them, or if they introduce RS-485 communication at a later date, is that only some 920s are RS-485 compatible, RS-485 communication compatible. And the way that you tell that on your controllers is this top sticker right here, and it actually tells you 920 series RS-485 communications option. So if you're ordering a 920 controller, make sure you get it with that RS-485 communication option included on it. But that's how you tell is if your module is RS-485 compatible. I'm not sure if nVent still does it, but if you had older 920 controllers, some of the versions will allow you to upgrade with this if you get the chips, but I'm not too sure if nVent still offers that as an option.